Hello friends, in the previous video we have seen T section. See, in this video the I section is given. We are taking problem on I section. See the given problem. I section is 240 mm deep and its flanges are 160 mm into 10 mm as shown in figure. Calculate the moment of inertia. See, in the moment of inertia, we have seen L section, then T section. Now this one is the I section. See, in this given diagram, flanges are given. The dimension of flanges are 160 mm base and 10 mm depth. Bottom flange is given. This one is your bottom flange. This one is your top flange. See, here the wave is given. Total depth is given, that is 240 mm. This width is given, that is 10 mm. See, in this diagram, the important thing is that neutral axis is also given, that is NA. See, two dotted lines are given in the problem. You can see this dotted line, this dotted line. It indicates that diagram it's symmetrical about x-axis and y-axis. See, why I am saying the diagram is symmetrical about x and y-axis? Because here we are considering the center lines, means horizontal center line and vertical center line of the given diagram as a vertical and horizontal axis. So you can see this diagram. Previously, I told you while solving any problem of moment of inertia, the dimensions are very important. The diagram is very important. We have to draw the diagram very clearly. See, you can solve any problem by using different methods. But during the exam, what we are doing, we are choosing less time consuming method. So different techniques are there to calculate moment of inertia. But here we are choosing the less time consuming method. I will explain you the different methods also. But here, see, we have to calculate moment of inertia for this I section. Already I have explained all the dimensions. Now our first step, you all are aware with the first step to calculate centroid position, because from centroid the horizontal x-x axis and the vertical y-y axis will pass. So if the diagram is symmetrical about this vertical center line and horizontal center line, then x bar and y bar will be 0. Means you can directly draw y-y axis as a vertical center line and you can draw x-x axis as a horizontal center line. See, the diagram is very important. The previous method was different. In the previous problem, in the L section and T section, we did by using different method. Here we are using different techniques. See, in this diagram, what we are doing, we are considering the entire diagram as a rectangle. See, see the cursor position. This is the entire rectangle. And if you will minus this rectangle, this one is the first rectangle, which we have to minus from total rectangle. This one is the first, and this one is the second. So you can see first diagram. This is the given diagram. You can see the second diagram, and you can see third diagram. See, each and everything is given in the diagram. All the dimensions are given in the diagram. Total depth is 240 mm. This base distance, that is 160 mm. So here, this one is your base. This one is your depth. That is the rectangle. If you will minus these two rectangles from this rectangle, you will get I section. So, what will be the Y bar? If you are considering total depth is 240 mm and this is baseline, and if you are considering baseline as a horizontal axis, then from baseline the Y bar will be 240 divided by 2, that is 120 mm. So we know that how to calculate the centroid distance, centroid point distance from X and Y. Here we have to calculate moment of inertia about X axis. So if you will take the moment of inertia of a bigger rectangle minus moment of inertia of two similar rectangles. Now you can see here, this diagram is nothing but this minus this. So bigger rectangle dimensions are 160 base and depth is 240, and here the base is 75 and depth is 220. Because total distance is 240, the top plane depth 10 and bottom plane depth is 10. So 240 minus 10 minus 10. So the distance will be 220. And here the total distance is 160 mm. So from vertical center line, this distance will be 80. From this point to this point, distance will be 80. 80 minus this distance, that is 10 by 2, that is 5. So 80 minus 5, that is 75. Distance is given here. So here you can see moment of inertia about x-axis, BD cube by 12. Again the formula will be BD cube by 12. You will get the moment of inertia about x-axis. Here by putting the values, you will get The answer 51.22 into 10 raised to 6 mm raised to 4. The units are very important. Whenever you have to calculate moment of inertia about y axis, here Iyy plus Iyy2. Here Iyy is equal to Ig1 plus Ig2 plus Ig3. Again, we know that how to calculate the things. The formula will be dB cube by 12, dB cube by 12, and dB cube by 12. See, about y axis, this one is the first rectangle, that is 160 by 10. This one is the second rectangle, and this one will be the third rectangle. Now we have all the dimensions. So accordingly, for the first depth is 10, base is 160. Formula is dB cube by 12. Again dB cube by 12. Here dB cube by 12. Because here what we are doing, we have to take a distance depth as a 10, base as a 160. So similarly, you have to calculate Ig1, Ig2, and Ig3. Whenever you will put the value of base and depth, you will get Iyy is equal to 6.8449 into 10 raised to 6 mm raised to 4. See, I want to explain the very important thing. This is a very simple problem because the diagram is symmetrical about vertical as well as horizontal axis. So here the calculation part is very less. So you can solve this problem by using this method. Means here from larger rectangle minus smaller rectangle, you will get the answers very fastly. But whenever you will consider a symmetrical eye section, you have to use our regular method, means the method which we already use to solve for L section and for T section. Similarly, see this problem, an asymmetrical eye section having following dimensions. The top flange is given, that is 16 to 20 mm. Bottom flange is given 100 mm into 20 mm. The bottom flange is given. Wave is given. This is your wave. See, if you consider this diagram, in this diagram, if you are considering this one as a center point, then vertical center line of this entire diagram, see the cursor location, vertical center line. If this is the vertical center line, then the diagram is symmetrical about y-axis. But here the top flange dimension and bottom flange dimensions are different. So this is an asymmetrical eye section. So you have to use regular method. See, this is your diagram. Again, I am telling you to solve the problem on moment of inertia. You have to calculate centroid point. For each and every problem, the centroid point is very, very important. That already we studied in the engineering mechanics. See, this is your given diagram. Draw this diagram very carefully. Already, I have given E notes, E contained to you. You have to refer that E contained for more understanding. Here, just see the diagram. The diagram is very important. Observe this diagram very carefully. Given diagram. Then here you can see the given diagram. Top flange, bottom flange, that is wave. Distances are given 100 into 20. The wave, that is also 100 into 20. The top flange 60 into 20. See, this I section is divided into three rectangles. The first one, that is 100 into 20. Second one, that is 20 into 100. This one is 60 into 20. Area 1, area 2, and area 3. So here we have taken the value of A1, A2, and A3. It's area 1, area 2, area 3. These are the rectangles. So base into depth, base into depth, base into depth. So 100 into 20, 20 into 100, and 60 into 20. You will get the value of area 1, area 2, and area 3. See, you have to use the regular method to calculate the centroid point. So here, the diagram is symmetrical about vertical center line. So the x bar will be 0. Just consider that vertical center line as a y-axis. Then x bar will be 0. So you can see the x bar is 0 because the diagram is symmetrical about this y-axis. So in this diagram, just we have to calculate only y bar. We know that how to calculate y bar. To calculate y bar, y1, y2 means from baseline to first center point, second center point, and third center point is very important. This one is the first center point, this one is the second center point, and this one is third center point. Centroid point of the first rectangle, centroid point of the first rectangle, centroid point of the second rectangle, and centroid point of the third rectangle. So distances will be y1, y2, and y3. All distances from base only, because here the diagram is not symmetrical about horizontal center line. So you have to calculate y bar. So here y1, y2, and y3. Already you know how to calculate y1, y2, and y3. Then also I am explaining. For y1, this is the first rectangle. This is the first rectangle. The depth is 20 mm. So 20 by 2, you will get answer 10. Already you have the list of formula. Y2 is equal to 100 by 2 plus 20. See, this distance is 100. So centroid point will be at 100 by 2, but you have to take from base. So 20 plus 100 by 2. So the answer will be 70 mm. Similarly, for y3, this 20 plus this 100, that is 120, and the centroid point will be here. That is your centroid point of the third rectangle. So 20 plus 100, that is 120. 120 plus 20 by 2. So you can see the y3 is equal to 130 mm. So we know that y bar is equal to a1y1 plus a2y2 plus a3y3. Three areas are there. So for each and every area, y1, y2, and y3. We have the area 1, the value of area 1, area 2, and area 3. Similarly, we have the distance of y1, y2, and y3. So whenever you will put all the values in the given formula, y bar is equal to a1 y1 plus a2 y2 plus a3 y3 upon summation of all the area, that is a1 plus a2 plus a3. So here, see in the equation, y bar is equal to a1 is equal to 2000, y1 is equal to 10 plus a2, that is 2000, y2, that is 70, a3, that is 1200, y3, that is 130, and the summation of all the areas, that is a1, a2, and a3, that is 5200, is equal to 60.77 mm. So from baseline, you have to draw one horizontal line, that is x-axis, the distance from baseline, that is y bar. You can see this vertical distance y bar. Now again, the method is same. To calculate moment of inertia about x-axis, the formulas are same. Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. We know that we have to use parallel axis theorem. So parallel axis theorem, that is Ig for Ixx1, Ig1 plus A1H1 square. For Ixx2, that is Ig2 plus A2H2 square. For Ixx3, that is Ig3 plus A3H3 square. So for each and every rectangle, the formula for moment of inertia about centroidal axis, that is BD cubed by 12. So Ig is equal to BD cubed by 12. Here again the formula is same for Ig2 and for Ig3. So you can see Ig1 is equal to, for first rectangle, the base, that is 100 and depth, that is 20. So you can see 100 into 20 cube by 12. For the second, you can see the base as a 20, and depth is 100. For the third, base is 60 and height is, depth is 20. So here you will get the value of Ig1, Ig2, and Ig3. That is 100 into 20 cube by 12, 20 into 100 cube by 12, 60 into 20 cube by 12. That is Ig1, Ig2, and Ig3. Plus for Ixx1, A1H1 square, A2H2 square, A3H3 square. You can see the diagram. The important distances are H1, H2, and H3. That already I explained in the previous problem also. Already we have the value of A1, A2, and A3. So while putting in the equation, you have to use the value of A1 for the Ixx1. For Ixx2, you have to put the value of area 2. For Ixx3, you have to put the value of A3. That already you have. But while putting the value of H1, now here I am directly explaining you. You have to take the difference between y bar and y distance. Difference between y bar and y distance. Difference between y bar and y distance. See, here the value of y bar is 60.77 and y1 distance, that is 10. So for ixx1, the value of h1 will be 60.77 minus 10. For ixx2, the h2 distance will be y2 minus y bar. For ixx3, the h3 distance will be y3 minus y bar. So h1 is the difference between y bar and y1, or you can say the y distance of a particular diagram. So here you will get the answer for ixx1, that is 5.22 into 10 raised to 6 mm raised to 4. ixx2 is equal to 1.837 into 10 raised to 6 mm raised to 4. And ixx3 is equal to 5.792 into 10 raised to 6 mm raised to 4. Whenever you will add ixx1, ixx2, ixx3, you will get the value of I. So ixx is equal to 12.85 into 10 raised to 6 mm raised to 4. This is the answer for ixx. See here, I want to explain you the very important point. See, in this diagram, just see, diagram is symmetrical about y-axis. So for first, second, and third, the centroid point of a first rectangle, centroid point of the second rectangle, and centroid point of the third rectangle is passing through the vertical axis y. So here not need to consider parallel axis theorem, because here for the vertical axis of a first rectangle and vertical axis of a entire diagram is similar. So the distance between them is 0. Again, the same for second rectangle, same for third rectangle, because YY axis, YY centroidal axis is passing through the centroid point of the first rectangle, centroid point of the second rectangle, and centroid point of the third rectangle. So while calculating IYY, H1, H2, and H3 distances will be 0. That is very important thing in this diagram. So here you can see, not need to use parallel axis theorem. Here directly the value of IYY is equal to IYY1 plus IYY2 plus IYY3. So IYY1 is equal to IG1, IYY2 is equal to IG2, IYY3 is equal to IG3. So in the previous case, it was IG1 plus A1 H1 square. But here, H1 distance is 0. H2 distance is also 0. H3 distance is also 0. So not need to consider H1, H2 and H3. Not need to use parallel axis theorem in this problem. That is very important thing. So here, again, formula is dB cube by 12, dB cube by 12, dB cube by 12. That is the formula for moment of inertia about centroidal axis. We have all the dimensions of each and every rectangle. So accordingly, you have to put the value first depth, (20 into 100 cube by 12). For the second, 100 into 20 cube by 12. And for third, 20 into 60 cube by 12. You will get answer IYY is equal to 2.094 into 10 raised to 6. See here, again I am telling you, here not need to use parallel axis theorem, because here see in this diagram the centroid point of the first rectangle, centroid point of the second rectangle, and centroid point of the third rectangle is passing through the single line, that is centroidal axis of an entire diagram. So H1, H2 and H3 for IYY will be 0. So this is your answer for IYY. In the next video, we will see the C section. Thank you. Thank you very much.